We have the technology now to solve the aging problem, and we're not focusing much energy on it because it doesn't match the business models of big companies or big government, and it's completely ridiculous. You can see with COVID-19, you can see the amount of energy and enthusiasm the world is able to put when it really gives a shit about something. Suddenly trillions of dollars can be materialized. Suddenly everyone's life is totally upended and we're all living a different way than we were before. You know, if we can disrupt our lives and spend trillions of dollars because of COVID, like, why can't we spend trillions of dollars and disrupt our lives much less in order to solve aging, right?
Forever young, I want to be forever young.
Today is April 21st, 2020. I'm BrentNally. Please make sure you like, subscribe, and hit the all button there after you've clicked the bell. It really helps trigger the algorithms, and it's your best chance at helping us get this information out so you can hopefully increase your health span and lifespan. Also, make sure you check out the show notes. We're going to have extensive show notes with timestamps in there and this fun conversation that we're going to have with my guest that I have here. And also check out lifespan.io, otherwise known as LEF. Their YouTube channel is fantastic, and I just started doing long-form interviews on their YouTube channel as well. I had an interview last week with Dr. Alex Zhavoronkov, the CEO and founder of In Silico Medicine, where we talked a little bit about longevity, and we focused on how that relates to COVID-19. And we're going to be talking about this today with my awesome guest who I'm really excited to talk with here, Ben Goertzel. Ben, thanks so much for being here.
Thanks for having me. I'm looking forward to our chat.
Definitely. So let's give you a proper introduction first, and we'll talk about a little bit about how this interview came about. So I've been a big fan of your work for about 10 years, and I saw you speak at RADFest this year. It was my first time attending RADFest, last year, October 2019. And RADFest stands for the Revolution Against Aging and Death. And Ben was a great speaker there. I got to find you next to your wife and your kid right at the very end when we were about to leave on the last day. So I'm really excited I got to meet you in person and excited that you're so gracious with your time to do this with me today. And you're also a TEDx speaker. You're a writer for Forbes. You've written multiple books. I highly suggest the audience goes to Amazon and type in Ben Goertzel to find some of the incredible work that you've done over the years. You're the CEO of Singularity Net, which brings AI and blockchain together to create a decentralized open market for AIs. Also go to Goertzel.org. You're the chairman of AGI Society. AGI stands for Artificial General Intelligence. We're going to get into that in this interview. You're the chief scientist at Mosey Health. You're the vice chairman of Humanity Plus, chairman of OpenCog Foundation, and you have a PhD in mathematics from 1988. So you're technically Dr. Ben Goertzel, but I don't think that many people call you doctor, even though you've earned that prestigious award. Or that prestigious honor. So finally, your passions are numerous, including AGI, life extension, biology, philosophy of mind, PSI, consciousness, complex systems, improvisational music, experimental fiction, theoretical physics, and metaphysics, and much, much more. So there's your proper introduction. You've seen him on Joe Rogan. You've seen him on London Real with Brian Rose, which we probably need to talk about what's going on with that right now with censorship. And you've also seen Ben on much more things, hopefully. And if you haven't yet, then I highly recommend it. Check the show notes. All right, there we go. Ben, thanks so much for being here.
All right. Yeah, thanks for having me. We've got a lot to talk about.
So what would you prefer to start off with? Because I just hit the audience with a lot of credentials, a lot of things you're interested in. What is most pressing to you right now?
Well, the center of my work and my career has been on AGI, artificial general intelligence, as you mentioned in your introduction. Of course, that's a medium-term pursuit. We're not going to achieve human-level artificial general intelligence, AIs that can really think like people tomorrow. I mean, it could be years, but it's not going to be days. So there's a lot of shorter-term projects I'm involved in as well, applying AI to life extension with the Rejuve project, applying AI to help with COVID-19 in various ways. So yeah, I think we can talk a bit about AGI and the grand vision and what we're aiming to do there to, transcend human intelligence in a profound way, but also about shorter term things that we're doing with incremental steps toward AGI to use currently available AI technologies to do things like help with human health and human life, which is what I was talking about at the RadFest event last year, where we intersected face to face.
Definitely. That sounds like a great place to start it off. And, obviously we're going to get into COVID-19 and how this relates to longevity science that's long overdue to be funded. It's very little funding going into anti-aging longevity science. And so I think that for the longevity community, this is our opportunity to get the message out to the world that if you really are scared of COVID-19, the best thing you can do is become biologically younger, because 99% of people under the age of, people over the age of 30 are 99% of all the deaths. People over the age of 50 are 95% of all the deaths. If you believe the government statistics, which we could get into that as well, because, there's the Mark Twain quote, there's lies, there's damn lies, and then there's statistics, right? So, and governments have a lot of incentive to falsify information. And there's over 200 nation states on the world working together. And I want to see if maybe flu statistics have gone down, and maybe other causes of death have gone down, because that would be interesting as well too, to see how statistics might have been manipulated on that. But let's jump into however you'd like to the AGI. And before we jump into that too much, about a month ago I interviewed Peter Voss, and I believe he's the one who created that term. And he kind of told a story in that interview about how he's an older gentleman. He wanted AI. AI used to be this AGI, like general intelligence, as smart as humans and smarter than humans type of idea. And over the last few decades, unfortunately, AI has moved into more narrow AI, how a lot of these companies are using it. So I believe you're one of the folks who really, really want to get back to the original vision of AI from the 1950s or so. So that's why the AGI had to be AI had to be rebranded to AGI.
Yeah. Let me go a little bit through that history, and along the way we'll explore the question of whether or in what sense Peter Voss introduced the term AGI, which is a sort of a footnote. I think the concept of AI and AGI is very, very old, right? I mean, the ancient Chinese purported to have human-like robots walking around in ancient China thousands of years BC. And I think while the term AI was coined in the late 1950s at a workshop at Dartmouth College, if you look back earlier at, for example, Norbert Wiener's book, Cybernetics, The Science of Control and Communication in Man and Machine, which was the 1930s, I guess. I mean, the basic concept that a machine can do what a brain can do using similar types of information processing. I mean, that was there in fully refined scientific and mathematical form a couple decades before the term artificial intelligence was posited. And I'm not sure Wiener, who coined cybernetics, would have liked the term AI, because his view would be that engineered systems or evolved systems, I mean, they're just physical systems displaying, intelligent control properties. He wouldn't necessarily have viewed an engineered AI, an engineered intelligent system as more artificial than an evolved one. But anyway, the term AGI, when it was formulated in the late 1950s, really, it mostly meant AIs that could think in a similar way to people. And, initially not quite as smart, then as smart as people, then later maybe even smarter than people. And, in the late 50s, the early AI researchers at that point thought it would be a few years till they could make a machine as smart as human beings. And you can see why they'd think that, because, I mean, machines could already do long division problems and huge square roots, calculations that only very smart people could do. So if they could do these calculations that only really smart humans could do, certainly it shouldn't be that hard for them to like read a children's book or draw a simple picture or walk across the street, right? But as it happened,
Possible.
yeah, as it happened, we discovered over the next decades, the 60s and 70s, that some of the things that are hardest for people are easy to get computers to do, and some of the things that are easy for people are actually harder to get computers to do. And we can now see why that is. These things that are easy for us, I mean, the reason they are easy for us is mostly that evolution has spent a long time preparing the human brain to do these things, right? Whereas the things that are hard for us, they're hard because evolution didn't prepare our brains to them. We had to learn them through culture and education. So there may be more complex processing going on in reading a simple story or walking across the street than in calculating a square root or solving an algebra equation. It's just we don't feel that processing because it's the processing it's wired into our brains in a way that's unconscious to us, right? So that process of discovery happened, and the result was that the AI field started focusing on what was easier to do, which is making AIs do specific narrow tasks, many of which are things that are hard for people because they're things that we learn to do culturally rather than we're prepared to do evolutionarily. So you had some things that aren't even considered AI now, like computer algebra systems that came to prominence in the 60s and early 70s, which are now inside tools like Mathematica or Maple, which we don't even think of as AI, right? We think of them as, these are just software tools, right? Or I mean, face recognition, we now consider AI, but it's sort of verging into just being a function of your phone or of a security camera, right? So
Whereas maybe 10 years ago, facial recognition, full blown as it is today in 2020, was still kind of like argued upon by really leading thinkers in AI.
yeah, people were saying
it happened, and 10
people
years
were
later,
saying it might be impossible. That's right.
Right.
So this is the series of steps that has commonly happened with AI functionalities. Is first people say, well, only humans can do this. It's too hard for machines to do. It needs human intuition and inspiration and, radical voodoo human biology magic. And then, okay, an AI is made to do that thing, but maybe in a way not so similar to how human beings do it. And then people say, well, okay, but that's a trivial function. It doesn't touch the magical core of what makes us human, right? So at a certain point, solving algebra was the magical core of humanity, but arithmetic wasn't. Then face recognition was relying on the magical core of humanity. But now people will say, well, but understanding what's happening in a movie scene, that's too hard for AIs. Or proving math theorems is too hard. Or making a hit song, it's too hard. It's too creative. But, one by one, we may get narrow AI systems that can do those particular things, and then the AI skeptics will say, well, that just proves those things weren't very hard.
When normally those were the same
place.
people that were saying for many years, if not decades, that those things were hard. So at least in some way they're contradicting themselves with that. And I've heard your good friend Ray Kurzweil talk about this quite a bit. And it leads me to point out a very important fact, which is that humans are the most adaptable creatures to our environment. That's something that people should really, think about. And especially with COVID-19 right now, we're seeing who is prepared to adapt for an environment like this and who not. My life hasn't changed much. I'm raising a 5-month-old son. I got my wife here. I'm an entrepreneur doing YouTube videos here from home and on Zoom and Skype all day, meeting with people all over the world. My life hasn't changed that much right now. Other people have been impacted dramatically. So I want people to think about where technology is heading. We don't want this interview to just be turn it on, turn it off, go back to your life. We want you to think about how this interview and the amazing things that Ben is already talking about and is going to be talking about can actually impact your life if you take that change? Because that's an important message for my audience, Ben.
Yeah, and I mean, part of the reason that you and I have not been impacted as much by COVID-19 as some others is just that we have more resources at our disposal. I mean, if you're low income and you're living month to month, paycheck to paycheck to pay your rent, there's not much wiggle room. And I mean, availability of resources, abundance is important. I mean, I'm not extraordinarily wealthy. You may not be either, but if you have enough wiggle room that, I mean, having an income impairment for a few months isn't an existential crisis for your life. You can weather something like this much better. In the same way, availability of computing resources is part of what has enabled AI to accomplish more and more and more over time. Because, I mean, with the computing resources we had in the 1950s. Oh, wow.
All right, we got a little one coming
We got
up.
a visitor. What do you say? Do you want to say hi?
Much
With
better.
the computing resources we had in the 50s, you weren't going to make AlphaGo. I mean, no matter how smart your code was, it just required a lot of memory, right? And it required, you know, multiple GPUs working in parallel to train the neural net models to play Go. So the availability of greater computing resource, I mean, that doesn't solve the AGI problem in itself, but it creates the conditions for that greater adaptability and flexibility.
It's like AlphaGo.
We've got a complex series of dog removal operations.
No worries. How many dogs do you have?
Two dogs, two poodles. Yeah.
Okay, we have one little white, fluffy, hypoallergenic dog because I'm allergic and I don't want dogs shedding all over the house or cats. So we love our little fur baby. What I was saying about AGI and AlphaGo and Google's DeepMind, there's a really good documentary on Netflix that kind of explains how this all kind of came about. And, you know, it's the same story you were alluding to earlier where it's like, hey, this will never happen. Go's too complex. It's, you know, blah, blah, blah. And then they do it. And then it's kind of like, it wasn't that big of a deal anyways, is what kind of people move on with their lives.
Yeah, but still, if you look at the difference between human intelligence and the generality and scope of intelligence that people have versus the very brilliant narrow AIs that we have now doing specific things like drive cars or play Go or prove some classes of math theorems and recognize faces. I mean, there is an element of adaptive creativity, imagination, agility, and breadth of thinking that people have that current AIs do not have. I mean, so as one kind of random example, like in computer music, we could train an AI to make a new jazz tune or a new K-pop tune or something. You feed it a bunch of jazz or a bunch of K-pop, it understands the patterns. And I mean, so far it can't make new jazz at the level of like Coltrane or Monk or something, but it can make like a smooth jazz indistinguishable from what you'd hear in the dentist's office, but it's new and it's not just a copy. On the other hand, we don't have an AI that can invent a new genre of music, like the invention of jazz in itself, or the invention of hip hop, let's say. I mean, these were just breaking the assumptions of what had come before in fairly profound ways. I mean, they incorporated elements of what was there before, but they were doing something more radically new than what any current narrow AI algorithm is doing. And we don't want to exaggerate the breadth of the human mind. I mean, we're certainly specialized in some ways. Like if you ask me to run a maze in 750 dimensions, I'll probably get lost very quickly. Whereas a maze in 2 or 3 dimensions, I'll do better at, which is because my brain has some specialized wiring for, 2 and 3 space dimensions, 1 dimension of time. So we are specialized in certain ways, but much less so than current artificial intelligence systems. And you could even say humans are around the minimal, generally intelligent system that is able to understand how stupid it is. Like we're just barely generally intelligent enough to A, know that we are generally intelligent, and B, know how limited our general intelligence is, right? And I don't think dogs, cats, or monkeys are there. I don't know about dolphins and whales. And I know that our current narrow AIs are not there. Like, they don't understand how narrow they are. I understand how narrow I am, and that's a significant difference. That means we're over some threshold of general intelligence, which is the threshold that has allowed us to develop, mathematics and science and engineering and modern culture. And being beyond that threshold of general intelligence is what will allow us to create by engineering rather than just foster by being the grounds for evolution. It will allow us to create by engineering minds that are more generally intelligent than us. So there has been an exponential increase of intelligence since the emergence of life on Earth. And I think there's going to be an inflection point happening around now, which, as Ray Kurzweil says, we're going from exponential to hyper-exponential. There's an inflection point occurring now, which is going to be the shift from evolution as the primary driver of intelligence increase to engineering and rational design as the primary driver of intelligence increase. Not that evolution in the broader sense is done, because science and math, they're driven in a way by trying a lot of random things, and some will fail, some will succeed. But there's also a reasoned design process on top of it, right? And we're generally intelligent enough to create these reasoned design processes. Current narrow AIs, while maybe more general than the narrow AIs of 10 or 20 years ago, they haven't reached that critical threshold of generality that human beings have. And this was clear from when I started my career. I mean, when I was a kid in the 1970s, I grew up reading science fiction and looking at like robots and Star Trek and Space 1999, and then reading Heinlein and Asimov and Stanis Salem and Philip K. Dick, all these science fiction writers, which have AIs and robots and AGIs and super intelligent oceans and all sorts of wild things, group minds combining various people. I read Douglas Hofstadter's book, Goertzel Bach, in the late 70s, which didn't use the term AGI, but made clear the difference between, very narrow problem-solving systems and artificial computational creativity. Then when I started in university and then graduate school and looked at what was going on in the AI field, it was like, well, this stuff is boring. They're like coding in rules to tell the computer exactly what to do. Like, where's the intelligence there? Where's the imagination there? So I ended up studying math and then cognitive science and going off to the side of the traditional AI field. And when I was choosing a PhD topic, I wanted to do something on recurrent neural networks, cross-connected neural networks for predicting time series. And no one would supervise the thesis on that because it was too weird and radical. Neural nets were so unpopular then, which is funny for me now because I'm sort of in the position of saying, well, neural nets are okay, but they're not the whole solution to AGI, right? But when I was doing my PhD in the late 80s, it was more like, well, neural nets are pretty cool. Let's play with them. Let's see what they can do. But the academic establishment was like, that's too radical. That's weird. We only want AIs that will follow the exact rules we give them, right? So I did some academic stuff in math and computer graphics and cognitive science, trying to come up with mathematical models of the mind. In the late 90s, I co-founded an AI company with 4 other people in New York City first was called Intelligenesis. We changed the name to WebMind. And we were trying to build a thinking machine that was distributed across the whole globe, like just have different parts of it on different servers around the world. And through the coordinated activity, you would get an emergent intelligence through the whole web. That was the WebMind. Ironically, one of our junior AI developers in that company, WebMind in New York, was Shane Legg, a guy from New Zealand, who moved between our New York office and our New Zealand office in Hamilton, New Zealand. And Shane was pretty young then. He was just getting started in the AI field. He was interested in building thinking machines. We certainly filled his head with a lot of new stuff about artificial general intelligence. And yeah, many years later, Shane went on to co-found Google DeepMind, which was interesting. I mean, Shane was very bright, but a lot of the guys in WebMind were very bright. And I have to say, at that point, we didn't pick out Shane as like the golden one who was gonna co-found something huge among all the other also brilliant people there. So this gets back to the community with Shane, myself, Peter Voss, and a bunch of others that led to the coining of the term AGI. In, I guess, 2002
was around like, yeah, I was going to say 2003 is what Peter Voss told us.
Yeah, so I was together with Cassio Penashine, who was my collaborator on AI, starting in 1998. I mean, now we're still working together, actually. I started editing a book, and the provisional title was Real AI. I mean, I was talking about building thinking machines that could think like people, but you know, I started to feel like Real AI was too aggressive of a title in the wrong sort of way, because I mean, Narrow AI is also real. It's doing real stuff. It can be valuable, but it's just not general intelligence, right? So I was struggling to come up with another title. We were looking at like, okay, maybe, you know, synthetic intelligence, synthetic cognitive systems, and we had a lot of ideas, and we had an email thread where we were tossing around different ideas. And Shane first was suggesting cybernetics after cybernetics from Norbert Wiener, but I thought that sounded kind of dorky and wouldn't catch on. And as I recall, Shane was the one who suggested artificial general intelligence. In fact, not Peter Voss.
Peter Voss may have said like I don't remember exactly, but he may have said that he was like part of it, you know. So
yeah, there was an email list with like 15 or 20 people, including me, Peter Voss, Shane, Marcus Hutter, and basically everyone who contributed a chapter to the book Artificial General Intelligence. So as I recall, I was sort of the ringleader. I was like, let's brainstorm a better name for this. We were tossing around all kinds of garbage. Shane threw out, well, why not GAI or AGI? And we didn't like GAI because it sounded like gay, and gay isn't popular among everyone. I mean, I think I was in favor of it because gay is happy, gay is cool. Like,
yeah, that's the original word.
Yeah, Nietzsche had a book, The Gay Science, which I was a big fan of. But
the words definitely changed in the vernacular over the last.
Yeah, and in Chinese, you still say general artificial intelligence. You can't arrange it, artificial general intelligence. So in Chinese, but anyway, what I want the audience we settled on that for the book title. We published the book. We put it out there, and then in 2006, I started organizing an annual conference series on AGI, and it was that conference series as much as anything else that like pushed the concept out there. And part of why I liked that name when Shane, as I recall, proposed it was general intelligence in psychology is the G factor, which is what IQ measures. So you had sort of a grounded meaning for general intelligence in the psychology field. You have an IQ test that purports to measure general intelligence in humans. So then we're talking about, well, you know, how do you define the G factor beyond just humans? How do you define it across species? And of course, we don't have a good way, right? Like we don't even have an IQ test that holds up across cultures, really. We don't have an IQ test that we could take to some like Stone Age pygmies in the Amazon and use to assess their intelligence.
Right.
Let alone the general intelligence of, say, a humpback whale or something, right?
There's many different forms of intelligence, and that's what AI and AGI is teaching us. It's like, oh, you'll never do this, then you do it. Facial recognition, beat a computer, beat somebody at chess.
So what Shane did in his PhD thesis, working with Marcus Hutter, who's a good friend of mine, who was just last year finally absorbed into Google DeepMind. Marcus Hutter had a whole mathematical theory of general intelligence, where he explained how you could write a very, very short computer program that would be like maximally generally intelligent. The problem is it will be very, very slow and take more computing power than the whole universe has. But it's sort of a mathematical existence proof for really, really smart general intelligence. After our New York AI company closed its doors in the dot-com crash in 2001, after WebMind was gone, Shane went and did his PhD with Marcus Hooder, and his focus then was coming up with like a clear mathematical definition of what is general intelligence. And it was interesting because I had many debates with Shane in New York in the WebMind period. And at that point, in the late 90s up through 2001, Shane was saying that the key to creating artificial general intelligence is to define exactly what intelligence is. And it's because we don't have a rigorous definition that we haven't succeeded to build it. And I was always like, well, you know, we don't know what beauty is, and we can paint a beautiful painting. Biologists don't know what life is. It's kind of fuzzy. Is a virus alive or not? But yet, you know, we can still do synthetic biology without having an exact definition of life. So Shane went away. He learned a lot of math. He did some amazing work for his PhD, coming up with a formal definition of what's general intelligence. And having done that, he decided that wasn't the key to creating AGI after all. He started studying neuroscience, and then he went on to co-found Google DeepMind, which is initially was founded really on a deep neural net and deep reinforcement learning approach, not trying to derive AGI from the formal definition.
Right, and DeepMind got acquired by Google, so it didn't start off as Google either, right?
It got acquired by Google, and then they recently have hired Marcus Hooder and a bunch of others working on the deep formal theories of intelligence that on top of which Shane was building his formal theory of what is intelligence. So there's an interesting sort of dialectic between getting abstract and trying to formalize things and getting concrete, using the brain as inspiration, using computers for whatever they can do best right now, and just trying to build stuff, right? We've had that dialectic between theorizing and building, both in the field as a whole, in Shane's career, in my career, and in DeepMind. And I guess, I mean, that's just like experimental science versus theoretical science in other domains.
Okay, very interesting. And just to share my background, I have a corporate communications degree. So I studied a lot of linguistics, semantics, the history of language, things like that. I think I'm pretty decent at marketing now. I have about 15 years experience, 10 years experience in Silicon Valley doing enterprise sales. And so I'm actually going to be interviewing Aubrey De Grey in a couple hours, the founder of SINS Research Foundation. If you have any questions for Aubrey, I'm going to be interviewing him soon. And I interviewed him last year in his office at SINS. And so I'm a co-founder of a company called LEV Sciences, or LEV Sciences, which stands for Longevity Escape Velocity. We're probably going to rebrand because of the same problems you've just been discussing, right? You have AGI. It's kind of a computer nerdy word. It has very important ramifications for the actual scientific field in mathematics and physics. But when it comes to branding and popularizing these ideas to a general audience, which I think is really important, is what I'm trying to do. I think a better word for AGI would just be super intelligence. Just be very direct on what you're actually trying to build, because we don't just want human.
Well, that ship has already sailed, though, right? I mean, Nick Bostrom published a book, Super Intelligence, which specifically uses the term to refer to intelligence that's way, 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 way smarter than people. And AGI can mean systems that have the same level of general intelligence as a human. It doesn't have to be a Bostrom-style super intelligence. But in the AI field... I
agree the ship has sailed. I'm just kind of saying in a perfect world, and it's kind of like frustrating. It's the same thing. Yeah. My sophomore year of college, I took a course. It was called Women, Men, and Society. And I was really young and dumb, and I didn't realize that I was walking into a feminist course. And my first initial reaction was, they say they want feminism, they want equal rights. I was like, well, why don't you just call yourself equalist, right? That's what you say that you want. But I think when we pigeonhole ourselves into a marketing tool that's just like too narrow, it can sometimes, in the long term, it's bad. In the short term, it's good. So it's a trade-off, I feel like, when you're trying to brand and market.
Well, that goes back to John Maynard Keynes' statement: in the long term, we'll all be dead, right? So,
Yeah, that's
I
a good
mean,
point. That's a really good point.
which
Hey,
is
Ben,
what we're trying to avoid with super longevity, which is another term I like.
perfect. So let's get into all that. The story you've just told has been incredible. Maybe we can segue into what we first talked about in the interview about what you and your team are working on right now. I know you were at Hanson Robotics and you helped develop Sophia, and we could talk about that at some point. But now you're at Singularity Net and all the other things that you're working on that I introduced you at the beginning of the interview. What are the, because we got about an hour left. What are the big takeaways on those things that you want to talk about?
Yeah. So let's we should go through all that. So let me
And you can
start.
you can finish your story there that you were going on if you think if it wasn't concluded properly with the whole kind
That's
of
fine.
development.
That's fine. Let's talk about OpenCog, which is an open source AI project I started in 2008, building on some software code that Cassio and I and others had started writing in 2001 or so, shortly after our New York AI company WebMind shut down. So OpenCog is an open source software project aimed at artificial general intelligence, initially at the human level, maybe beyond. And it's a multi-paradigm approach. So you have a knowledge hypergraph, a bunch of nodes and links representing all sorts of knowledge connected together. And you can have multiple AI algorithms acting on that same knowledge hypergraph. So you can have neural networks, you can have a logical reasoning system, you can have an evolutionary learning system that tries to evolve new information. You could have any sort of AI algorithm, and they all cooperate together in real time at updating the same large knowledge hypergraph, right? And it's hard to build. It's harder than building a single paradigm AI like a neural network or a logic engine. But I came to believe already in the mid-90s that the best approach to creating like a practical AGI system, with current computer hardware and with the level of knowledge that humans have, the best way to do it was going to be a sort of multi-algorithm approach where you use neural nets for what they're good at, logic systems for what they're good at, evolutionary algorithms for what they're good at, and mix them all together in the right way within the same unified AI system. So that's been fascinating and also very challenging to work on. We've been evolving that system for a while, and it's been fascinating to see the practical successes that have been had with more single algorithm approaches, which are, I think, more limited in their ultimate potential, but they're easier to customize hardware for, they're easier to optimize and scale up. And so neural nets and deep neural nets as a single algorithm approach, I don't think they're going to go as far as something like OpenCog, which combines these multiple algorithms in a unified framework, but they can do some amazing things now, right? And so we're hitting on both the strengths of deep neural nets and what they've been gotten to do and their weaknesses now, and we're hybridizing these deep neural nets with OpenCog, which is a sort of more profound and advanced but less mature approach. And we're looking at this combination of deep neural nets with OpenCog in applications to longevity biology and to aspects of understanding and coping with COVID-19, along with a host of other applications, and controlling the Sophia Robot as well. So one aspect of this sort of hybrid multi-algorithm approach to AGI that we're pursuing in OpenCog is Neurosymbolic AI, which is it's a buzzword that more people can understand than like a hybrid multi-paradigm AGI system, but it just sort of scratches the surface. Like Neurosymbolic is about putting together a neural net with a symbolic system, like a logical reasoning engine or automated computer program learning system.
Is it actually recognizing symbols, like it sees a tiger and it knows that's a symbol, and or is it?
Yeah, and relationships, right? So like if it sees a tiger eating a lamb, then it wants to recognize like there's an eating relation occurring between the tiger and the lamb, and if a system can abstract that sort of symbolic relationship out of the low-level pixels in an image, then it can maybe do some reasoning about that abstract symbolic relationship, and it may be able to infer, well, maybe the tiger will also like to eat a goat because it's something similar to a lamb or something. So in that kind of neurosymbolic application, you're using the neural net to do the vision processing. And then once you've abstracted some relationships, like, oh, there's an eats relation between the tiger and the lamb. Once you've extracted those relationships from the neural network, then you can do some symbolic logical reasoning on top of that. And the logical reasoning can also then bias what the neural net is doing to help it recognize things better. So if it's very low lighting or something, maybe the neural net can't see that well what the tiger is eating. Based on the symbolic abstraction, you could guess it's more likely to be a goat than a motorcycle or something, right? Because you know by reasoning that you know the tiger has been seen eating a lot of living things, and you have that abstraction of living things. So
right.
that
And the tiger is a living thing, and living things don't normally eat, big, large, non-living things.
No, although there is some French guy ate a whole bicycle once. So I mean,
there's always exceptions to the rule.
Yeah.
Probably infer certain things.
The internet has exceptions to almost every rule on it, right?
And the English language has a lot of exceptions too. Super cool. Okay, so that's OpenCog.
So that's OpenCog, and I mentioned that because that's sort of a core engine at the center of a lot of more practical things that I'm doing. Because this is one of the challenges in communicating about AI work, because what the end user sees is the application. Yet as a researcher, you're really thinking about the underlying algorithms and data structures, and the application is sort of a layer that's on top of it. And but that's the same thing as with each of us as humans, right? I mean, the big story is often what weird stuff is coursing around inside our heads, but other people have this annoying habit of paying attention to the look on our face or what we're saying or the clothes we're wearing or something, right?
Right,
So
or maybe the hat we're wearing or something like that, right?
Yeah, it's the same with an AI, right? I mean, we're focusing more on the algorithms and structures. Is it a hybrid architecture? Is it a neural network? But of course, the application is equally important. And it's important for interface between the AI and people, but it's also important because that's how the AI learns, is by being able to interface with the external world, right? Because how can an AI that I program be smarter than me? Well, it's mostly because the AI is given sensors and actuators to interact with the outside world, which has much more complexity than I do, right? So I can build something, I can put my own knowledge and savvy into it, I can give it the tools to interact with the world, then it can poke the world.
Right.
And
it's the same way my wife and my wife and I created my son. I hope that one day he's more intelligent than me. That's how it should go, so why can't we do the same thing with computers?
Right, because we're creating these human children or mind children. We're creating them in a way that lets them independently interface with this world that we all share. And this world is astoundingly more complex than our own minds. And we cannot know what our human or mind children are going to mine and poke and prod out of the world that they're embedded in. So I don't know how many times people say, well, it's a paradox. How can a human create something smarter than a human? Because we can only program in what we know, which it just seems crazy, because you're programming the system to extract its own knowledge from the world, which has relative to us an almost infinite complexity. So yeah, let's talk about some specific applications of AI, and of both neural net and logical and hybrid AI.
And if Ben, if we can focus that to longevity, because my audience is focused on longevity.
Yeah, we will.
That's what you're focused on as well.
So let me briefly go through the Sophia Robot.
Yeah, that's important.
Which you mentioned, and then we'll jump into we'll jump into COVID-19 and other annoying sources of death and human destruction and suffering, which we want to eliminate all of them so that humans can live a long time, and we can upload ourselves in this Sophia version 42.0, right?
Yes, sir.
So this Sophia robot, I mean, that's a specific engineered system which has some non-AI bits and some neural net AI bits and some symbolic AI bits, and they're integrated together in a beautiful and kind of ad hoc way to make an overall operating robot. And a self-driving car is not a bad analogy. Like you've got a navigation system, you've got a system for pedestrian recognition, you've got a system for tracking other cars, you've got a braking control system. You have a bunch of specialized systems leveraged together into an overall automotive control system. And it's not yet that the car is learning how to drive in a holistic way like a person does. It's more you have a bunch of narrow AI systems that are networked together within a holistic application architecture that people designed. And Sophia is sort of the same way. She's not a general intelligence yet.
Can I real quick, before you move too far from that, I'm a Tesla investor. And so personally, I think that Tesla is tackling the self-driving cars in the most intelligent way. So if people don't know, just real briefly, about 3,700 people every single day die globally from car accidents. So we don't just want to solve aging, human aging. We also want to take the other 40,000 people that are dying every single day from other things. And when it comes, I think Tesla is doing this in the best way, where all of their cars, even if they're not ready to be full AI self-driving, they have those capabilities once it gets there with software updates. And Tesla is gathering information on all of their cars that are on the road, whereas all the other car companies, Google, Waymo, the other car companies, GM that are trying to solve AI, they're doing it in a different way, where they're paying software engineers $180,000 a year or something to go out in a car and go around and scan data. And so I just think the way that Tesla's doing it is so much smarter. And I don't know if you have any opinions on that or if you've looked into it. I also understand I'm biased as a Tesla investor.
One of my opinions is the smarter your AI is, the less data you need.
That's a good point too.
I mean, gathering data is important. I don't have knowledge of whether Tesla is really gathering more data than, for example, many Chinese car makers.
Oh, they're gathering way more data. They have literally more than 10 times the amount of data. So
Than anyone in China?
Than anyone anywhere. So, and it's because they have more cars on the road, and they're getting data for every single thing on those cars. Because
I can see a head start there. I guess as a devil's advocate view, I guess because China is a very centralized country,
right?
All they would have to do.
That's why Tesla merged with China. Basically, they did a great deal.
Yeah, but all the Chinese would have to do is command every car maker to put some data gathering box in every car. It'll be done, and in a month they'll probably have 100 times more data than Tesla.
Well, so that's why I said Tesla's kind of partnered with China, with the government. Yeah. They got special incentives,
They have.
They have.
I would say.
I think Elon Musk and Tesla has a very strong track record of open source.
Partnering with the Chinese government has a very checkered record of success.
Right. That's a good point too.
So I guess clearly Tesla is being a pioneer in terms of gathering data, and the cars are amazing. I don't own one personally, but on the other hand, in terms of the underlying AI, for example, Toyota probably has 50 times as much AI firepower as Tesla as a company. I mean, looking at it just from an AI point of view, Tesla is going all in on deep neural networks. They're hiring people from OpenAI. And if deep neural networks are going to solve that problem as a narrow AI problem, maybe Tesla will get there first. If it's going to take a broader-minded AI approach, Tesla doesn't have it at the moment. They're extremely narrow-focused on a particular AI approach, more so than, for example, Toyota, which has an amazing AI and robotics research division that's been around forever and has many billions of dollars just on the AI and robotics R&D
Right.
side.
Ben, I understand all that. I think the big thing that maybe I didn't clearly state is that Tesla has different type of sensors than any other car company on the planet, including China. And they're gathering all that data in real time, feeding back to Tesla, and no other car company is doing that.
I get it. I guess my own point of view is with deep neural networks, if you're restricted to that type of AI, you need insane amounts of data.
Gotcha.
Which is because what these algorithms are doing is recognizing a lot of very small and shallow patterns in a large data set. And if, as you go further and further toward AGI, then you need less and less extreme amounts of data. And for example, I can drive reasonably well. I haven't seen nearly the amount of data that Tesla has gathered in my lifetime, but I can drive better than their cars, right? And I didn't evolve that much for driving either. That is, a limited form of generalish intelligence.
Yeah.
So I think if no one manages to apply neurosymbolic AI or something more clever and abstract, then whoever has more data will win. But
you make really good points there, Ben.
It's not obvious, right?
It's still not obvious. And thank you for sharing all that. Obviously, you're super intelligent with this stuff.
Well, I would also say at this moment, Tesla has just hired a bunch of guys who believe neural nets are the only path to AI and the ultimate solution to AGI. And that's not written in stone that Tesla will always be taking that approach to AI either, right? So I mean that's it. Or they could sell the company to Apple, which is terrible at AI. So a lot of things could happen.
Yeah, it's when you introduce the business world and things like COVID-19 that kind of can really sway the business world and economies. Who knows? Because that has effects on the research of computers to some extent. So I apologize. You were talking about Sophia.
No, but this is good. This helped to flesh out some points about neural nets and other types of AI in a concrete context, which it's the same issue you see in biology or any other application of AI. Is this contrast between systems that are recognizing large collections of simple patterns in vast amounts of data versus systems that need to make do with smaller and messier amounts of data. So they need to be able to generalize and abstract more, right? And what you see now is something like face recognition, where you have so many pictures of faces that the space of human faces among like non-deformed people is covered fairly well by the images that Facebook or Chinese government or Google has in their database. So that's an area where deep neural nets can do very well, because they need huge amounts of data to do their recognition of a large amount of simple patterns, versus a domain where there's not so much training data available, like say a new disease like COVID-19 or something. You don't have that many cases and you don't have that much data on the cases that are there. So you just don't have the ability, you can't apply a deep neural net to solve the harder problems there. Humans have a big advantage over any sort of narrow AI in a case like that, where there's something new and you have to think on your feet in terms of like heuristically drawing inspiration from other prior cases. I mean, that demands more general intelligence, because you don't have enough data to cover every conceivable situation within the domain. Now, something like AlphaGo, you could do simulations, and you can play billions of simulated games, even if there's not enough Go games played by humans. But we don't have like a full-scale simulation model of the human body to do. We can't simulate 10 billion COVID-19 patients with accuracy to do like AlphaGo, right? So right now, deep neural nets and related AI methods where you have incredible shitloads of training data fitting a certain narrow application, or where you can do a simulation of a certain narrowly defined domain so as to generate that training data. And if you don't have either of those, then you need people, or you need AGI, or in a few limited cases, you could make some sort of rule-based AI system or something. And I mean, it's because of that that in building a self-driving car now, or a Sophia robot now, it's more like an engineering control system, which is connecting together a bunch of different narrow AI components, right? So Sophia can use narrow AI to recognize people's faces, and the dialogue system has some neural net aspect that can generate new creative responses, and it also has some rules that were basically coded by human narrative authors that emulate her personality. And it can sort of combine the neural generated stuff with the rule-based stuff. And I'm now working with Hanson Robotics on upgrading that so the neural net generated stuff occupies more of the dialogue than the rule-based stuff, whereas in the previous version, the rule-based stuff has occupied more, and the neural net only pops up now and then for more creative replies. But it's a carefully engineered system where you have like one neural net to generate voice, one to recognize faces, one that helps the rule-based system to inject some creative replies in terms of generating the text of the reply. So I mean, Sophia is neither as smart as some people think. Like, wow, it's an AGI. It looks just like a person. She looked me in my eyes. She really loves me, right?
There's been some criticisms in media for that, and I'm glad you pointed that out.
Yeah, but nor is she as stupid as some of the critics say. Like she's not teleoperated by people in normal operation, although she can be. And she's not just Eliza with a rule-based script either. There are various AI learning systems that are interoperable.
Ben, on that note, how much of Sophia is in the cloud? Is everything going on in her brain right there, or is there a lot going back to a big
data? It can be. So one of the subtle things with Sophia is you can run her in many different ways. Like you can basically have her recite a script, which is done sometimes when she's giving speeches. You can run her with her brain connected to the cloud, which lets her leverage more online information sources and large neural models running in the cloud. Or you can run her based only on local computers. Like she has computers in her torso. She can be connected by Ethernet with another local computer. And often, like in a conference venue, the internet connectivity is very bad. So they wind up running her based on just servers that are running local to her. But to get the most intelligence out of her, she has to have cloud access. Yeah, so that's, but when you talk to the robot, like you don't always know which version of the software is underlying the given conversation. And I can't always tell based on a brief dialogue either. I mean, you have to talk for a while to know whether she's accessing the cloud in that dialogue or not, actually. I mean, it's quite tricky because like for you or me, we have the same brain. I mean, you might be drunk or half asleep, but it's the same brain, right? With a robot, just because it's the same face doesn't mean it's the same software behind that face each time you talk to her. It could be a different version of the software completely, but we by habit think of it as like the same Sophia, the same entity each time, but it isn't, right?
Okay, perfect. And so I just last night, in preparation for this interview, listened to the Joe Rogan interview that you were on again. I saw it when it came out. I believe it was streamed live December 8th, 2018. Currently has about 1.6 million views on YouTube. I highly suggest people watch it. I'll have a link in the timestamp in the show note below. I believe in that interview, you said at the time, Sophia, there were multiple of them, and that Sophia speaks English, Russian, and Chinese at the time. Also, for those that don't know, in 2017, Sophia was granted citizenship from Saudi Arabia, which is an interesting country to grant citizenship with some of their, human rights violations and things like that. But nonetheless, it just shows you how the future can be very unpredictable and stranger. The truth can be stranger than fiction sometimes. So in any event, what can you share on updates with Sophia? How many of them are there? Also, it looks like, according to your LinkedIn, you're no longer an employee of Hanson Robotics, but you said you're still working with them.
We have a research collaboration between SingularityNet and Hanson Robotics, and so we're still working on upgrading the AI of Sophia step by step, and we should have some interesting announcements of some major upgrades to Sophia to announce this summer, actually. So I'm not an employee of Hanson Robotics, but David Hanson's a very close personal friend, and we're still actually collaborating closely together. And they've made some real breakthroughs on sort of scalable manufacture of the face material, new versions of the rubber face material. So they, as a company, they've been working a lot just on refining the engineering design so they can move to large-scale manufacture of the Sophia robots. And they've solved a lot of problems there in terms of refining the material design of the face so that it can be more reliably mass manufactured. What I've been working on is helping to upgrade the sort of cognitive dialogue model behind Sophia. I'm working closely with David on that, with the SingularityNet team in Hong Kong. But yeah, I guess I should do a few minutes of explaining what is SingularityNet, and then we can finally plunge into how to not be dead, which is the main thing here. But we're all building up there. All these things play in. So
how many Sophias are there right now, Ben? There's multiple, right?
There's dozens, yeah.
Okay. And was there any type of, outline that you can share with us on just business plans? We won't hold you to this if we're watching this 5 years from now, but what's the goal? Is there going to be hundreds, thousands in a few years?
Well, whether there's hundreds or thousands of Sophias is a business decision for David Hanson to make. But certainly the medium-term plan is to mass manufacture robots of that nature. I mean, some would be called Sophia, some will have other names and characters. But yeah, the goal is to go toward mass manufacture of humanoid robots. And there we come back to what you were discussing regarding Tesla, right? I mean, once you have humanoid robots out there in businesses and homes and walking down the street, the amount of data ingested from all these humanoid robots is going to be incredible, right? And that data will fuel so much learning about human common sense interactions, much beyond what a car will learn from driving data anyway. I mean, maybe not beyond what a car will learn by eavesdropping on the people sitting in the car, whatever they may be doing. But I mean, what humanoid robots will learn while going around and being your butler or your maid or your receptionist or your sales robot or your travel guide. I mean, the amount of
X-Robot for some people out there.
Yeah, Hanson Robotics has specifically avoided that market so
That's
far.
Smart.
But others will certainly take it up, right? So yeah, the amount of data and the amount of practice the robots will get in doing these things is incredible. And this actually is what led David Hanson to co-found the SingularityNet blockchain-based AI project with me. So when we started SingularityNet,
time to show my Bitcoin share.
So here we've got SingularityNet t-shirt. That's even better than Bitcoin, right?
Yes, sir. Yes,
to the singularity and beyond. So yeah, I mean, what led David Hanson and I to co-found SingularityNet, along with Simone Giacomelli, a young blockchain engineer who was my friend as well. I mean, David saw, once we roll out Sophia robots all around the world, and there's millions or tens of millions or billions of them, there's so much data being gathered about what everyone's doing in their everyday life, right? And who owns that data? Is that owned by, the Chinese government? Is it owned by Google or Facebook? Because people clicked something they weren't thinking about on the license agreement when they got the robot? Or is it owned by the people who generated that data, who the robot is watching and learning from, or by the person who owns the robot, right? So it was clear we would need a robot mind cloud which had scalable and secure data management. And we could see that blockchain was how you do that, right? So we needed a scalable, blockchain-based, secure data management platform for the army of Sophia-like robots that we wanted to roll out. And that's why David was so excited to partner with Simone and myself on founding SingularityNet, which is this blockchain-based AI marketplace. And we did an ICO for that in late 2017. And with the money we raised in that ICO, we've now rolled out this blockchain-based decentralized AI marketplace and platform, running for now on Ethereum blockchain, though we may make it multi-chain in future to run on many different blockchains. And basically what that means is anyone can put an AI out there in the cloud, and the AI will then talk to the other AIs that are in the Singularity Net network. And these AIs, they can provide services to anyone who requests services and negotiate payment. The AIs can pass data to each other. They can outsource work to each other, and the AIs can cooperate in solving problems, but all without any central owner or any central controller. So any data that's there, any AI processing that's there, it's owned by whoever happens to have put up that AI agent, and you don't need a central authority. Just like the internet doesn't need a central authority, which is why, like, Iran is still on the internet, even though many governments don't like them, right? So I think we need the AI that is going to bring us from where we are now through AGI and through super intelligence. We need that AI to be more like the internet or Linux than, like, you know, the mobile phone ecosystem or Microsoft Windows or OS X. We need it to be open and decentralized, and that's going to be more and more important as AI gets more and more intelligent and starts to pervade more and more parts of our lives. And we see all these issues in the application of AI to the medical domain and longevity and COVID, as well as to everything else. So, you know, regarding Singularity Net, you can look it up at singularitynet.io. We just launched a new feature to that product called the AI Publisher, which makes it really easy for anyone to put their AI out on the Singularity Net platform. So we're trying to beef that up and make it a, you know, a viable alternative to Amazon and Google Cloud and Baidu and Alibaba for AI developers to put AIs online that are serving various functions for various customers. And that applies in every vertical market, because it's just, how do you make any kind of AI operate in a decentralized network that communicates with other AIs in a way without a central controller. One of the applications I've been most interested in terms of applying Singularity Net and applying OpenCog has been in the biomedical domain. And I mean, this is both because it's just very intellectually interesting to study how the human body works, but it's also because I don't want to get sick. I don't want to get old. I don't want to die. Well, I'm already getting old. I'm 53, but I don't want to get sick and die.
And you look very good for 53, by the way, in my opinion, especially being a grandfather. And you have 5 kids. Is that accurate?
As far as I know, I have 4, unless you know something I don't. But yeah, who's the expert?
4 and a grandkid, right?
Yeah. I have 4 children, age, I think 30, 26, 22, and 2. And one 2-year-old granddaughter as well.
Who was born first, the grandchild or your last child? Yeah,
my son Quarksy, his name is QORXI, which is an acronym for Quantum Organized Rational Expanding Intelligence. Quarksy is 2 months older than his niece Umea, so he's kind of a brutal uncle. He likes to steal his niece's pacifier all the time.
Did you ever see that movie Father of the Bride Part 2 with Steve Martin back in the early 90s, where they had Steve Martin and his wife, who were older, had a baby at the same time as their daughter in the movie?
I didn't. No, I remember Steve Martin from The Jerk. I remember who the guy was.
Father of the Bride was phenomenal. It was a favorite movie as a kid. We're going on a side route here, but check out Father of the Bride and Father of the Bride Part 2. You might find some very interesting things in Part 2.
Yeah, I mean, in any case, I want to live to see my great grandchildren, right? And I think
not enough greats to say on this call. We're just saying great the whole time.
Yeah, exactly. Live, right? I mean, the vast majority of the time, I really enjoy being alive, and you know, I have no evidence that the alternative is better. So for the time being, I'd rather stay alive than dead. You know, my mom is in her mid-70s. I think she's 75, almost 76. She's about to retire for the second time, but I imagine she's going to rejoin the workforce again at some point. I don't want my mom or dad, who were both alive, to die either, right? So I mean, I think we must abolish the plague of involuntary death, and this is is an achievable thing. I mean, the human body can be viewed as an intricate molecular machine, even if there's some spiritual aspect to life that goes beyond that. That doesn't apply. We can't keep the molecular machine going a very, very long time. And I think we will do that. It's a matter of when. Will it be 5 years from now, 20 years, or 200 years from now? Well, I'd like it to be
2,000 or 2 million. Like, this isn't promised. I tell my audience, like, get involved, be part of it, be part of the change. There's things you can do. Figure out what your skill sets are. Share this video if you can. Like, subscribe. All that stuff helps. Follow
yeah.
on social media.
I want it to be 5, 10, or 20 years from now,
Yes.
not 200 or 2 million years from now. And it is a hard problem. You know, there's a lot of things you can do to help address it. And a lot of it is biology lab work. It's developing new measurement techniques, new gene therapy techniques. A lot of combating aging, disease, and death has nothing to do with AI. On the other hand, I think it's very likely AI is going to play a critical role in combating death. And I mean, this is something I've debated with my friend Aubrey De Grey about a number of times. And you mentioned you're going to interview Aubrey shortly. I mean,
Yeah.
Aubrey began doing AI also,
Right.
and
In the
he's
80s.
longevity research, and he pretty much believes, at least when I last talked to him, which was a few months ago, I mean, he pretty much believes that right now AI is kind of off to the side of the most critical things to do for advancing longevity research. And I understand where he's coming from, because there's a lot of lower hanging fruit. I mean, there's a lot of things that may work already, and we just need more testing and more lab work. And pertaining to the notion of longevity escape velocity that you alluded to earlier in the call, I mean, if we can do something simple that's not AI based at all, that, you know, will allow us to extend our lives by 5 years beyond what they would be otherwise. I mean, maybe in those 5 years, the AI will then discover something that will let us live 20 years longer than that, and then that iterates. And that's the Methuselarity, as Aubrey called it, or the longevity escape velocity. And
Definitely, Ben. Do you have a particular question that you want me to ask Aubrey? I'm interviewing him in about an hour and 20 minutes.
no, I mean, I talk to Aubrey all the time, so
Okay.
I mean, I'm always curious for updates on the specific projects that the SENS Foundation is funding, right? I mean, as I see, Aubrey and I have known each other a long time, since before longevity research became even as well as accepted as it is now. And I think we've each played a dual role.
Hey, Ben, I apologize. Do you maybe mind moving back to where you were a little bit earlier? My editor. Yeah, thanks. That's perfect. Sorry.
Yeah, I think we've each played sort of a dual role in our respective fields, and we've been doing our own actual work, and we've been evangelizing, right? So I've been evangelizing more for AGI, though a bit for longevity. He's been evangelizing more for longevity. And clearly, Aubrey's been amazingly successful as an evangelist for longevity as a viable goal. He's also been leading a bunch of specific research projects aimed at addressing various causes of longevity. So
I'll focus on that then, Ben. I'll ask a lot of questions.
If you want to ask him a hard question, ask him what he's doing to combat stiffening of the extracellular matrix.
Okay.
Because that's one of the hard parts that we don't really seem to have a good drug approach for. I think Christian Schaffmeister at Temple University, he has these novel engineered polymers called spiroligomers, which I think could be used to make a molecular scissors that would cut through the glucosapine molecules in the extracellular matrix. But that's, I mean, Aubrey's not doing it. I'm not doing that. And as far as I know, Christian isn't well funded to do that yet either. You should interview Christian, actually. He's an amazing guy. But,
could you put me in touch with him?
Yeah, sure.
Okay, we'll sync.
But I mean, so that's an example of, you know, that's something that someone should be doing to help combat aging. Like you can use spiroligoma molecules. They're engineered molecules. They're not traditional proteins. They're novel protein-like molecules. You could use them to make a molecular scissors that would cut through cross-linked glucosapane molecules in the extracellular matrix, which would solve one of the many, many things that goes wrong as we get old and die. You might be able to use AI to help design those molecular scissors from the spiroligomers. That's a very interesting neuro AI application, right? And I guess what Aubrey is looking at is there's a bunch of different things he sees how to do to, you know, clear out gunk of broken fragments of protein running through the body to help mitochondria from accumulating damage. There's a bunch of things he sees and he knows how to do that we just need lab work to refine them and turn them into therapies. Whereas the way I've been looking at it is more like, okay, cool, that's true. There's a bunch of specific things we should be doing to combat aging. I can see what they are, you can see what they are. On the other hand, we don't have a holistic systems model of everything that goes wrong in the human body as we get old, right? And we don't have a model of all these different systems, you know, the extracellular matrix, the mitochondria, the gunk building up inside all of our tissues as we get older, the neural degeneration that's happening, which causes age-associated brain disease, the degeneration of cardiovascular system, the things that cause diabetes in the blood. Like we don't have a holistic model of how all these things interact with each other, and there are snowballing effects that happen as you get older, where like, okay, your DNA repair screws up, then that screws up some other metabolic problem, which then causes DNA repair to get worse and worse. And we don't have a model of all these feedbacks that cascade as you get older and older to cause you to...
Everything in life seems to compound. Money compounds, math compounds, relationships compounds, and negative effects in the body compounds, you know, as well.
So we need, and positive effects compound, right? I mean, if you do intermittent fasting or you do a paleo lifestyle correctly, I mean, you can see and you can feel in your own body positive effects compounding, and you feel way, way, way better very, very rapidly. So you can have
talk about those things on my YouTube channel all the time.
Yeah, you can have both rejuvenation by positive feedbacks and degeneration by negative feedbacks, and you can have them both at the same time in different body systems. We need a holistic, comprehensive model of the human body, and this will be done by a combination of simulation modeling and AI, and we don't have enough data to drive neural net models for everything. And this is where I don't quite agree with my other friend, Alex Zhavoronkov, who I think said you interviewed recently. I mean, Alex is amazing. In silico medicine is doing great things. And they are bringing together simulation modeling with machine learning in a very, very interesting and impactful way. On the other hand, Alex is like our friends at Tesla. He is unhealthily obsessed with deep neural net models, right? And this is a mental disease all these guys will get over in a few years. But it's understandable because they've gotten great results using these models.
Right.
There's going to be a ceiling that you get to. And in biology, there are just some problems deep neural models aren't going to solve because the data isn't good enough. Now,
so maybe then for now, Alex is grabbing a bunch of low-hanging fruit, but you're saying that...
that's great. I mean, from a business view, it might be the right thing to do. Like if you have a technique that works and you have a team that can apply it well and software that does it, and you can find problems that are very amenable to that technique, that may be the best thing to do for making a lot of money and building a great company.
Yeah, and Alex is not going to solve investors right now.
It's not going to solve aging. So
Right.
Let me give you one example is how do you transfer knowledge from model organisms like mice and flies, as I worked with at Genesian, where we had flies that lived 5 times as long as normal flies. How do you port data from these model organisms to humans? Well, you know, you can see which genes of a mouse or a fly or a homologous or orthologous to corresponding genes in humans. But if you have a process like the process of, say, neurological degeneration in a fly, how do you port what's understood about that process to help understand neurological degeneration in humans? It's a little bit indirect because a fly's brain is not that much like a human's brain, although there are neural networks. parts in the fly's brain. So you need some analogy reasoning. You need some transfer learning, which is a bit loose and can generalize and abstract. So to do really flexible transfer learning from mice and flies to humans, so that we can take everything we've learned about aging or disease or death in model organisms and port it to humans, you're not doing that using current deep neural net technology. Human biologists are doing that using human creativity. We're working on that using OpenCog embedded in the Singularity Net platform, OpenCog combined with neural networks. But this is an example of something that has to be done holistically and has to be done using something that's a little further along the path to AGI than current deep neural net models. So I think that, you know, we may be able to come up with some miraculous things for prolonging human life without any AI, or using deep neural networks appropriately deployed, like Alex and others are doing. On the other hand, I think to really solve the aging problem in a compelling way, we're going to need to use integrative proto-AGI stuff like we're doing with OpenCog, and with OpenCog embedded and connected to other AIs in the Singularity Net platform. And you're going to need to take this integrative AGI approach, and you're going to need to apply it to many, many different body systems together in a holistic way. So it's going to be like at least proto-AGI integrated with simulation models for holistic understanding of the whole body. And then you'll need a feedback between experimental biology, clinical medicine, and AI, right? Where the AI is crunching data that comes from the clinic and the lab, and from people who uploaded the data from their wearables or whatever. The AI is analyzing that. The AI is applying some AGI to extrapolate from the data it's seen. The AI has suggested hypotheses that can then be tested in the lab and the clinic. The data from the lab and the clinic is then fed back into the AI, and you have this positive feedback going. And we've actually launched a project spun off from SingularityNet called Rejuve. And you can look at rejuve.io. And
I have links in the show notes below, guys. Check the timestamp.
So you can see what we're doing with rejuve.io there. What we're aiming to do there is create an ecosystem pulling together, you know, AI running in SingularityNet using OpenCog and deep neural nets for crunching data pertinent to longevity, clinics that are willing to try, you know, cutting edge longevity therapies and, you know, contribute anonymized data into Rejuve's data commons, labs where researchers are investigating, including investigating the hypotheses suggested by the AI, and then individuals who are interested to contribute, you know, data about their own bodies to Rejuve's data commons, which could be your electronic medical records that will be appropriately encrypted and shared in a privacy respecting way using SingularityNet's blockchain tools, or it could be data from your, you know, your activity tracker, or say a thermometer or a pulse oximeter or whatever that are connected to your phone. So you have individuals contributing data to this whole pool, and then Rejuve has a tokenomic ecosystem, which is Rejuve points. It's not really a cryptocurrency now. It's a point system, more like frequent flyer miles, where for contributing data into the Rejuve data commons, you can get Rejuve points, and you can then redeem those points to get discounts on therapies at member clinics and so forth. So we're trying to create a whole tokenomic ecosystem, bringing together clinics, researchers, labs, AIs, and individuals who are contributing data. And we're trying to get some of these positive feedbacks going, because, you know, in SingularityNet and OpenCog, we have amazing AI for analyzing biomedical data, but we need more data. Right now, most of the valuable data is locked up inside pharma companies, which is crap. That's not how it should be, because the data comes from us. It comes from our individual bodies.
We own,
why do these pharma companies own the data, right?
Right.
So
it's so important for people to understand what Ben is saying right now. You own your life, right? Voluntarism, all these ideas of like libertarianism things. It's where the world's going. It's a little scary with socialism globally for me right now, because we own our own life. We own our own data, right? It's either you own yourself or somebody else owns you. And right now, what you're saying, these big companies own way too much of our data. And
well, that's right. So I mean, you mentioned socialism. I consider myself an anarcho-socialist,
Yeah.
which is a tradition going back to Emma Goldman and Kropotkin, a whole bunch of political thinkers. I mean, I believe in socialism, in that each of us should be contributing to the common good. Mm-hmm. On the other hand, that has to be done in sort of a free and self-organizing way, not a manner that's dictated top-down. And what top-down medicine has gotten us is a relentless focus on repurposing already approved medicines for other conditions, which is what pharma companies are spending their hundreds of billions of dollars on now, and right. Trillions of dollars. And, I mean, what centralized top-down control of the medical ecosystem has gotten is a sort of oligopoly of big pharma and big government, which is not really trying to solve the problem of prolonging all our lives so we don't have to die, right? And
right.
We have the technology now to solve the aging problem, and we're not focusing much energy on it because it doesn't match the business models of big companies or big government, and it's completely ridiculous. You can see with COVID-19, you can see the amount of energy and enthusiasm the world is able to put when it really gives a shit about something. Suddenly trillions of dollars can be materialized. Suddenly everyone's life is totally upended and we're all living a different way than we were before. Why? Because, to our great, renown, I mean, we are caring about a few old people getting sick and dying of COVID-19. Like we care a lot if 5% of people age 80 or over die. And that's beautiful that we care about that. And we're willing to blow trillions of dollars and disrupt all our lives because we care if a certain percentage of old people and a much lower percentage of younger people will die. On the other hand, if we can disrupt our lives and spend trillions of dollars because of COVID, like, why can't we spend trillions of dollars and disrupt our lives much less in order to solve aging, right?
Ben is so beautifully said, and it's everything you just said. That's what I'm going to put in the very beginning because it was so emotional and so beautiful what you just said. And to hammer home the point that a lot of people still don't know is about 110,000 people are dying every single day from aging or age-related diseases. Yet this is not very well understood. And I think that if the public was more aware of this, we would have public outcry and we would get money invested in there. That's what a big mission, that is the biggest mission of me doing my YouTube content, to let people know we have a huge problem already right now. It's about 110,000 people dying every single day from aging or age-related diseases. And it doesn't have to be this way for all the reasons that you just stated.
Absolutely.
And so now everybody's freaking out over COVID-19, which is, hey, great, let's take that freak out and then shift it towards.
Yeah, I mean, COVID is bad. And my parents are in their mid-70s. I want them to live forever. I don't want them to get COVID and succumb to, heart or lung failure or something. And
right.
We're looking now at applying Singularity Net AI to help with COVID in a number of different ways. So we're using it to simulate the spread of COVID using agent-based modeling, so you can understand the impact of various policies better than is being done now. Because now we have these policies that are costing trillions of dollars to the world economy being put into place based on, some leader's gut feel or some very, very simplistic simulation models. So we're using Singularity Net and OpenCog AI to drive smarter simulation models. We're using it to help extract information from all the research papers on COVID that are online, so that your AI can understand what's in all these documents and can give summaries to researchers. And when we're using it to try to understand which COVID therapies, which antivirals might work for which people versus others based on their DNA. And, there's a lot of interest now in everything we can do applying Singularity Net and Rejuve and OpenCog to help with COVID, which is important. And I'm very happy that we have AI that can contribute to solving COVID and helping society cope with its aftermath better. On the other hand, all these things that we're doing with Singularity Net, Rejuve, and OpenCog to combat COVID, like, all these are the same things we can do to combat aging and death, which is a bigger problem. Because, I mean, I'm probably not going to die of COVID. I'm at a bit of risk. I'm over 50, but I'm in pretty good health for a 53-year-old guy. And you know, I'm not putting myself at too much risk now. I'm social distancing and all. On the other hand, in the end, if COVID doesn't kill you, heart disease will kill you, or diabetes will kill you, or
Let's look at this.
Something's going to kill you, right? So,
right.
I mean, we should be worried about COVID. We should also worry a lot about everything else that's going to kill us if we don't stop it. And, you know, if
there are levels of worries that we should have too. And currently COVID's killed, I think, about 150 or 60,000 people. I mean, I just said aging kills 110,000 people every day. So hopefully,
well, that's right.
People can just understand the numbers.
COVID is contagious, and aging is not contagious.
Unless you're around a bunch of people who eat potato chips and sit around, you know, in a way, you do kind of become the people that you spend time around. But it's not a communicable disease.
I think it is possible that for at least a small segment of the population, you know, the COVID pandemic may be a teachable moment regarding the much more severe pandemic of aging and involuntary death due to aging. I mean, I don't have the illusion that it's going to wake up most of the world regarding the imperative
idiocracy, unfortunately.
Of curing aging. But I think it will have that aspect. It's certainly focusing people's attention on their own mortality and on medical issues. And you can see, you know, COVID is going to be solved by science. We're going to get a vaccine. We're going to get therapies. In the same way, aging can be solved by science. And, you know, AI can be part of that science. And what we've built up in SingularityNet, which lets many AIs cooperate and collaborate on solving problems. What we built up in OpenCog, which lets neural net, symbolic logic, evolutionary learning cooperate together in one AI system to solve problems. What we're doing with the Rejuve, bringing clinics, labs, individuals, data, and AIs together. I mean, all these things are part of the network of science and scientists that we can use to cure and cope with not only COVID, but aging and all the other things that kill people. And it is ridiculous that society is not spending more effort on that. Like, you know, after the financial crash in 2008, Obama somehow synthesized $4 trillion to bail out large banks. Now suddenly trillions of dollars are being synthesized to help cope with social distancing and COVID. Good, but let's synthesize trillions or tens of trillions of dollars to stop aging. Like, we have the technology now. And, you know, I don't delude myself there's going to be a $10 trillion anti-aging bill passing through Trump's Congress anytime soon.
Right.
I mean, if we build up momentum with projects like Rejuve and Aubrey's work and Zhavaronkov's work and João Pedro Magalhães and all the rest of it, if we build up more and more momentum, you know, accelerating the increasing momentum we've seen behind longevity and anti-aging in the last few years, if we keep building that momentum, we may see the level of resources go into anti-aging that it has deserved for a long time. You know, we're one breakthrough away from that, I think, right? Just like with self-driving cars, it was, I guess, the DARPA challenge for self-driving cars in the desert, you know, which Sebastian Thrun and Google and Stanford contributed to. I think that was, 2015 or something?
Oh, gosh, that was like 2010. I thought I was taking
maybe.
I was taking a Udacity course led by Sebastian Thrun in 2011.
2010, yeah, maybe that was it. Yeah, 2015 was a robotics grand challenge. Yeah. So I think these DARPA challenges for self-driving sort of hit people over the head, and they're like, wow, self-driving is going to happen and someone's going to own it. So the same way, I mean, once we get a single therapy that's like FDA approved and licensed for prolonging your life, then everything's gonna pile on. And I don't know whether AI is gonna come up with that breakthrough, or whether it's gonna be good old fashioned gene therapy or something, right? But
good old fashioned gene.
But whatever it is, I mean, once we have that breakthrough and we have the first generally recognized therapy for extending human life with science, I mean, then you're going to see tremendous amount of resources, literally trillions and tens of trillions of dollars piled into prolonging human life. And AI is going to be a key part of it. Singularity Net, Rejuve, and OpenCog are going to be a key part of it. And there's going to be a lot of other parts coming in that we can't even imagine now. And you look a lot younger than me, so I'm almost certain.
I'm 61.
Yeah. I'm 150 actually. Yeah.
I'm 35.
I'm almost certain that you're going to hit longevity escape velocity. Ray Kurzweil.
As long as I don't get hit by a bus first, right? I tell my audience as well,
Yeah.
be careful, minimize risk in many ways.
Of course. I mean, in the future, it's going to seem insane that we were living without a continuously updated backup copy, right? No one's going to be able to imagine like how weird and scary it was to live.
I make like 3 backup copies of
backup.
my YouTube interviews. I wish I had a backup copy of myself.
Yeah. So I'm probably on the cusp. Like I should live another 30 years. I think we're going to make it in that time. But of course,
we're all working really hard to make sure that you make it. And I'm just trying to contribute with the skill set that I have by getting these ideas that you have, giving a bigger light to all these incredible scientists that you've mentioned and yourself and your team. And so Ben, I know that you joined a little late. Just so I know, I have a number of questions here we could do rapid fire. Do you have a few more minutes or do you have to run?
Let me check my handy Google Calendar here and see. I do have a few more minutes. Yeah.
Okay, perfect. If it's okay, let's do lightning round, and maybe for these, if we can, I'll try and maybe throw up some softballs and you can do shorter answers. Is that cool?
All good.
All right, so here we go, lightning round. So Starfish and the Spider is an incredible book about decentralization versus centralization. Have you heard of it and have you read it?
I heard of it from you just now.
Okay, it was written in 2010. I thought it was, it was written in 2008 before Bitcoin came out, and I thought it was interesting. You already know all these ideas. You were talking about decentralization in the mid 90s, but I think you might find it interesting.
Oh, cool. Yeah, that's true. You know what? My wife, who I've been with just 11, 12 years now, she dug up randomly a web page I put up in 1995 where I claimed I was going to run for U.S. president on the decentralization platform.
You mentioned that on Joe Rogan. That's super
very funny. Yeah, now I'm intelligent enough not to want to be president, but yeah, decentralization, that goes back to anarcho-socialism, right? I mean, that's a long-standing theme.
Yeah, definitely. It's really, really important stuff. And then I have a question from a friend of mine, Roen Horn, who is the founder of Eternal Life Fan Club. And he said, I saw you discuss Ex Machina on Joe Rogan. What do you think about the movie's slogan? There is nothing more human than the will to survive. And also, what's your thoughts about the movie's portrayal of AI?
I mean, it was a good movie. Clearly, they copied the look of that robot from Sophia Robot, which was originally called Eva, and then after.
And that was the name of the robot.
Eva, we changed Eva's name to Sophia.
Did you guys change that to rebrand from the movie, or was it a completely separate reason?
We changed it so people wouldn't confuse it with the evil AI in the movie. Yeah.
That's smart.
I mean, I think the movie probably copied it from us, from David.
I mean, almost certainly, right? Like 99% based off.
Very similar. I mean, the moral of that movie is if you are a raving psychopath and raise your robot child, that robot child may come out a raving psychopath.
Which is more reasons we need to take power away from governments and big corporations and put it back into, decentralized people, in my opinion.
Yeah, exactly. I mean, the vast, teeming, chaotic mess of humanity is screwed up, but it's less screwed up than an individual psychopath, right? And relative to human psychology, almost all governments and corporations are psychopaths. Like a government is single-mindedly pursuing its own hegemony and territorial integrity. A company is single-mindedly pursuing profit, right? And right. I mean, this single-mindedness.
Ben, I say on my YouTube channel all the time, it's all about the incentives that you set up for the structure of the system, and that's just the way that the governments and, you know, corporations are set up, you know, and it's not going to change in this
Well,
hierarchy.
governments and corporations are fairly narrow goal-achieving systems. Humans are something different. We're more open-ended, self-organizing systems, and we will pursue some incentives and throw them out and pursue other ones. Right? I think we're not well modeled as reinforcement learning systems, except over sort of limited periods of time. And putting AGI in the hands of these systems with very narrow and simplistic goals is not a smart thing to do. I mean, there's an argument that corporations are a sort of virus on human society, and putting AGI in the hands of these sort of meta-level viruses that are leeching on our society, even while they provide us with energy in certain ways. I mean, that's not a smart thing to do. And I mean, in terms of the drive to survive being key to biological organisms, of course it is, but that's too simplistic, because humanity evolved by a combination of individual and group selection. So, I mean, humans have a drive to survive. They also have a drive to help the tribe survive. And both the individual and group selection played a role in biology. In Ex Machina, you see the results of individual selection, but not the results of group selection. I mean, I think the tribalism that we see in modern politics with Trump and Johnson and all this tribalism is more group selection, right? Unfortunately, I mean, we've grown beyond that, but only partially, right? Because I mean, the human race is more general than any tribe, and also more general than the individual. And we're looking at creating new forms of mind now, right? And
Right.
I mean, we're, as David Hanson, who created Sophia, likes to say, you know, the ultimate ethos he can see is pattern is good. Generating new patterns that will then generate more and more patterns is good. And we're shifting toward that sort of pattern ethos where, you know, we're happy to create new cultures. We're happy to create new minds. We're happy to spawn new, wild, crazy, unfamiliar things. But while this pattern ethos emerges from humanity, a lot of humanity is still stuck in individual organism survival or tribe survival. And so we have this conflict. And I mean, these conflicts and tensions can be good. They can provoke growth, right? I mean, just like, I mean, in a love relationship, you want to have some tension along with warmth and compassion. And in driving toward creativity, tension often is what drives creativity. So, I mean, in me personally, I want my own organism to survive, even though I know I'm not all that important in the cosmic sense of things. I want my kids and mom and my friends to survive. I want the culture that I like to survive. On the other hand, I want humanity to survive. I also want, you know, new patterns to organize and flourish even beyond what is humanly comprehensible, right? And it's okay that we have goals for survival and growth on all these different hierarchical levels, and that tension of different overlapping goals, that's what makes life interesting, right? And we'll continue to, you know, after humans are no longer the smartest creatures around. But a movie is a very limited thing. So in a movie, you can harp on only one point, right? And the Ex Machina,
Right.
it's single point.
And unfortunately, most of the sci-fi movies, Ex Machina as well, are dystopian or have a dystopian ending with sci-fi, which is unfortunate.
I mean, sci-fi novels since the early part of the last century have been exploring all these themes with tremendous depth and nuance. And it seems that so far video as a medium has not lent itself to too much nuance in exploring AGI, longevity, or other transhumanist and singularitarian themes. But I mean, the nuance is out there in written science fiction in great depth. And maybe the next generation of filmmakers will come up with more creative ways to portray the depth underlying these topics.
Yeah, it's a goal of mine to participate in some type of movement to help that happen with a major Hollywood production movie, have a positive sci-fi, future.
I don't know if it'll be a major Hollywood production or maybe like some channel of TikTok videos or something,
Yeah,
right? It's not clear what form it will take.
Hey, Ben, so when I finished watching Joe Rogan last night, you guys ended saying, hey, let's meet up and do this again in about a year. Well, it's been over a year. That was December 4th, 2018. Any update on when you'll be on Joe Rogan next?
No, I haven't talked to Joe, but I should do it on my birthday again. December 8th is my birthday, which is when the last episode was.
Well, no, don't wait that long. You said you should meet up about every year, and it's already been over a year. So
well, right now I think it will be a long interview, because if I went to California, I'd have like 2 weeks of forced.
He did virtual interview with Edward Snowden last year. I know Edward's, can't leave Russia. But
yeah, video would be all right. I mean, 2 weeks of home quarantine with Joe Rogan would be kind of fun. We could take some mushrooms and lift weights and stuff. Probably a really good time, actually.
So just a reminder for you, we'd love to get you back on there. It's a big thing I talk about. I'm trying to get a lot of these longevity scientists on Joe Rogan because I know he's really interested in it. And
I'll do it. I mean, I've been in Hong Kong mostly, so it's a long trip. But I'm sitting on Vashon Island near Seattle at this point. So if our great leader, his Trumpness, should relax the travel restrictions, it'd be great fun to pay a visit to Mr. Rogan again.
Okay, got it. So you're stuck in America right now the whole time in Seattle. Okay, I just assumed you're in Hong Kong because I know.
No, I've been in Seattle for like a month and a half, and I guess my mom and sister live here on Vashon Island off the coast of Seattle. So I guess I will be stationed here until such time as I can travel somewhere else interesting without hitting a quarantine restriction. So.
Okay. Well, just a reminder, I'd love it if you can get back in touch with Joe Rogan and his team to get back on there. So Greg Fahy, you're familiar with this work?
Guy, yeah. I mean, Greg Fahy is amazing, 21st century medicine. And he, last year's RADFest, of course, he published a paper on a trial of a combination of therapies that seemed to roll back age to according to certain biomarkers, right?
It was HGH, DHA, and metformin on 9 men for 1 year time. And Steve Horvath was involved, the Steve Horvath clock at UCLA, and it showed from the, Steve Horvath clock, which is DNA methylation, it showed biological age reversal of these 9 men from about age 50 to 70 or so.
That's right. I haven't tried Greg's cocktail. Have you?
So I take metformin. I have not tried, and I take DHA, but I have not tried HGH. However, the most amount of HGH that produces in your brain is when you're sleeping, and I'm always talking about sleep on my YouTube channel. I've done a book review on Dr. Matthew Walker's book. He's the sleep scientist. He was on Joe Rogan, sleep scientist at UC Berkeley. He's a sleep scientist at Google. I've interviewed the sleep doctor, Michael Brews, who's on Oprah, been on Dr. Oz over 40 times, on tons of mainstream media. I'll interview him again. Sleep is so important. And then the research shows if you want to pump more HGH into your brain, which is really good for you, do just about 5 minutes of exercise right when you wake up on an empty stomach, first thing, boom. So that's how you can produce the most HGH in your brain from my research. So he's going to be continuing phase 2, and hopefully I'll be interviewing Greg Fahy.
I do have to go now, actually. My time window has expired here.
Okay, sure thing. We'll just end it right here. So Ben, thank you so much for being here. I really, really appreciate it. We hope to have you back on for part 2 at some times, because I have way more questions to ask at some point, and I really appreciate it.
Yeah, absolutely. We should talk again after the Rejuve project launches. We should have a whole bunch of other practical stuff to do.
Definitely. And I'd love to sync up with you to show you how maybe we can contribute. My co-founder at LEV Sciences, his name's Vladimir and he has a team of about 30 IT people that work for him that might be able to contribute nonprofit, like for free, just to start off. So we'd love to chat with you at first about that.
Oh, very cool. They're in Russia? What?
So he's in Russia, and some of his team is in Russia and Ukraine. So they're...
Yeah. our biggest AI team in SingularityNet is in St. Petersburg, actually.
That's where he lives. He lives in St. Petersburg and Moscow. He splits his time. So I'd love to, have a meeting with you just to show you what.
That'd be very cool. We've just been, the last couple months, we've been shifting some of our St. Petersburg SingularityNet AI team to working on bio AI stuff in OpenCog. So it would, if there's some folks local there who know about the longevity side, it could be quite interesting.
Elena Milova is somebody who we can get in touch with as well too. She's in Moscow. She's on the board of Lifespan.io. I've been building a stronger relationship with her.
Cool.
And next time, Ben, I want to get into billionaires, the big ones, how they can contribute. We know that they're somewhat interested in it through certain ways that I'll talk about next time. I'm talking about Jeff Bezos. I'm talking about Warren Buffett, Bill Gates, Elon Musk, Sergey Brin, Larry Page, Larry Ellison. I want these people to get involved in this, and I think I have some creative ways on how we can do that. We can talk about it next time.
I mean, billionaires, of course, can make a big difference with a single donation, but that's great, and we certainly would take substantial investments or donation for any of the projects I'm involved in. I mean, we're probably going to be raising funds for these various projects for a long time, but I think we're not going to wait for the billionaires, right? So I mean,
right.
I mean, with Rejuve, we're considering to do an equity crowdfunding just to get the little guys in, because all of us are going to die if we don't do something, right? And just like we can all own the data that we put in, we can also potentially own some of the therapies that are discovered from our data, and we can invest money as well as data in our longevity. So I mean, I think of course billionaires can make a huge difference. On the other hand, we can do this without any billionaires, just by leveraging data, financing, and brilliance contributed by all of us non-billionaires who are going to die if we don't solve aging.
Definitely. I just think that billions of dollars invested into this, your companies and SINs and other longevity focused companies could definitely help. I don't think it's going to hurt.
Well, no, I mean, merely additional millions would help most of these projects, right? So
yeah, definitely. So follow Ben on social media. You do have an Instagram account. I think you haven't posted in a couple of years. But
I've never used Twitter. Follow me on Twitter.
Twitter and also LinkedIn. You have 8,000 followers. You post some great stuff on there. We'll have links in the show notes below. How else can people either get in touch with you or support what you're doing, other than obviously just money?
Yeah, I mean, Twitter and LinkedIn are the best places to follow me. And if you keep an eye on Twitter, you'll see announcements of everything else that I'm doing. I mean, we're going to be doing a bunch of things related to the Rejuve project, including soliciting members and maybe some equity funding rounds and so forth. So if you follow me on Twitter, you'll see announcements regarding Rejuve and SingularityNet. I mean, if you're a software developer, we're running a hackathon now called the COVID-a-thon, which is aimed at bringing AI and blockchain together to help combat COVID-19. And as we were discussing, I'd like to keep that energy going even after COVID-19 is cured. But a lot of the same things we can do to help with COVID are the same things we'll want to do to help with aging. I mean, it's about using AI to crunch biology research papers and crunch genomic and medical data. It's about collecting information from wearables into a big data commons so we can understand the relation between lifestyle and health. So with the COVID-a-thon, we're gathering together, AI and blockchain software developers to help with combating COVID, but also, I mean, with promoting human health in general. So that's on DevPost, which is a hackathon platform, which I've also tweeted about, and that's mentioned on SingularityNet.io, which is the website for our SingularityNet project. So there's lots of ways to get involved, and and help out. And I get asked by a lot of people, how can I help with these causes? And indeed, if you're a biologist or a software developer, it's kind of obvious because we have initiatives in those domains. But in the end, there's ways that pretty much anybody on the planet can help with these causes. And the first thing to do, which you're already doing if you're watching this, is just to get educated. Because once you understand what the issues are and what is being done by the various people and groups on the planet to help with all these important issues, like are all getting old and dying. I mean, you'll see many ways that you can help, because there's a tremendous amount of need for people with all sorts of skills.
I completely agree, Ben. And simple things that people can do if you haven't yet, like this video, comment in the comment section below. It triggers the algorithm. And if you ask a good question for Ben, if I interview him again, then I'll ask your question on here. So it's a way that you can contribute and have your voice heard. Share this video on social media. It gets Ben's ideas out. Ben, we're in ideas economy right now, and Ben's given so many great ideas during this video. And then also remember, subscribe if you haven't yet, hit the bell, and then click all. YouTube's algorithms are so important to get this message out as well too. We have to work smart rather than just working hard. We have to work hard too, but just clicking all actually allows the algorithm to get this video up so Ben's voice can be heard even more. And then, finally, the thing I'll say is clean up your YouTube, unsubscribe from things that aren't serving you, turn on all on other longevity focused YouTube channels like lifespan.io, Leaf's YouTube channel, and other longevity focused content, because those little things can really help and they only take a minute. So that's my final little spiel. Any last words you want to leave with the audience, Ben?
Not that I can think of. Thanks for listening, everyone. And I think the main messages I want to get across, I've probably already told you. I mean, I think we're living in a unique and amazing time now, where we're years to decades away from creating AIs that are as smart as us, and then shortly after that, much smarter than us. And along the way to doing that, we're going to create AIs that can solve a bunch of small problems, like creating material abundance for humanity and curing death and disease. And it's up to us as a collective, whether this happens in 5 years or 50 or 500 years, and it's up to us as a collective, whether this happens in a way that kills 90% of the human population before we get to the singularity, or in a way that lets 99% of the people now alive, keep living to the singularity. And, of course, if any one of us was hit by a bus, probably the singularity is still going to happen, but it's the accumulation of all of our efforts that's gonna make either amazing things happen or amazing along with terrifying things happen, right? And I want to bias things toward the amazing and minimize the terrifying. And I think we've been over a bunch of the initiatives I'm involved with toward that direction, and I hope a good percentage of you listening will think about, like, how can you reorient your thinking and your lives so that some percentage of your effort each week goes toward promoting a beneficial singularity and curing aging and death and working toward abundance.
Beautiful, Ben. And if you guys can't, put in a lot of time, energy, and effort into those things, then, just follow me on social media. Consider donating $1 to my Patreon so I can keep going and keep interviewing people like Ben, and we can get to the bottom of this.
There you go. Follow him on social media and give him $1. That's my final word.
Give me $1, right?
All right. I got to go, man.
Thanks, Ben. You've been incredibly grateful with your time, and we wish you the best. Have a great day.
Forever young, I want to be forever young.